Welcome, geometry students, to section 1.8, area and perimeter. Shout out to Miss Gonzalez who drew this for me and sent it to my notes. Now, for those of you that are watching, I am going to try to keep this under 15 minutes. I actually just set a stopwatch, so I'm going to try and hold myself to that. Let's go ahead and jump right into this. So a polygon, what is a polygon? If we're talking about shapes and area and perimeter, we understand what are these shapes. A polygon is an enclosed space, shape, an enclosed shape, with three or more sides. Okay, so for example, we could have something like this, as long as it's an enclosed shape, and we can create these little diagonals or whatever. Right now I have 4 sides, there's 5 sides. Okay, so this is a type of hexagon. It's an enclosed shape, all the lines connect, etc. They're straight, bada bing, bada boom. Okay, diagonal. This is a segment connecting two non-consecutives, that means not one after the other, vertices. Okay, 2 non-consecutive vertices. Well, in red, I'll show you 2 consecutive vertices. So those would be 2 consecutive vertices. 2 non-consecutive would be in green. So we'd skip a vertex, and we go to the next one. That would be a diagonal. So that is a diagonal. Okay. A convex polygon has no external diagonals. They're all internal, external diagonals. Okay, so no non-2 consecutive vertices would be able to connect on the outside. So if I'm looking here, all of them, it looks like I can keep on the inside. All the diagonals are on the inside. Okay, what about a concave? Has one or more external diagonals. Now, I'm not a big fan of definitions and memorizing definitions. I just like you to know what it looks like. Get an idea of what these shapes look like. Okay, otherwise I'm not big into, oh, what's the definition of this? Okay, whatever. That's my personal class. Maybe your teacher is. Great. I mean, there's some value to that, but just know that I'm not like that for those of you that have me as a teacher and you're my student. Okay, so if we're drawing diagonals here, yes, it has some that are internal, non-consecutive, okay? But what about here? What if we connected these 2 points? Take a look at that. So we have an external diagonal here. So this is a concave, external diagonal. Okay, so that's an external diagonal, what that looks like. Area. Area is the space in 2 dimensions. Okay, so we're talking about the space in 2 dimensions. Now units are going to be units squared. For example, we would have square feet. You've probably seen this on floor plan, square miles, etc. Okay. Perimeter is the opposite. This is the distance around, not the opposite, but next level down, the distance around a shape. Okay, so the units are just going to be straight units like feet. Okay. Moving on. Area addition postulate. And if you want to pause this, jot down the notes, all great. If you don't want to jot this down, all great. Honestly, I'm not a fan of memorization as long as you understand the concept. Area addition postulate. Now, this simply states that a shape is the sum of all its shape components. I guess that's a way to say that. What do I mean by that? Well, take a look here. If we were to break this down, we could break it down. See, this isn't a shape right now, but we could draw it into 2 shapes. We could draw a rectangle here. Okay, a little shaky rectangle, but still a rectangle. And then we could draw another little rectangle here. And to find the area of this compound shape, so the area, let's make it green on the outside. So the area of the big shape would be equal to the area of the rectangle plus the area of the long rectangle. So see how it's a compound shape? It's the sum of multiple components, and that's the area addition postulate. So you can find the area of anything as long as you know the components that make up the compound shape. All right, some other shapes you need to know the basic information of. We have circles here. One thing you got to know about a circle, okay, if we look over here, this little distance right here is called the radius. So we got to know what the radius is. This is most often known as r. We also have to know the diameter. The diameter is, let me get a different color here, like this, okay. I want to move this up though. How high can I make it? There. So the diameter is 2 times the radius. It's the distance from one side of the circle through the center, and it doesn't look like it's through the center, diameter, and that's often as d, through the center of the circle. Okay, so that's diameter, that's the radius. Circumference, we're going to use a mathematical symbol pi. This is 2, whoops, I drew a 2, but didn't show up. Drew it again, didn't show up. 2 pi r is the circumference. So we multiply 2 times pi. Pi is approximately 3.14. I should write that approximately, shouldn't I? Okay, just for your reference. And the area is pi r squared. Okay, make sure you square the r first and then multiply it by pi. You wouldn't believe how many times people multiply pi and r and then square the result. Square the r first. Rectangles. Rectangles are shapes with 90-degree angles. Okay, they have length and they have width. Well, the perimeter is simply just adding up all the lengths and widths. Well, if you look at the lengths here, how many lengths are there? Well, there's 2 lengths and there's 2 widths. So the perimeter is as simple as 2 times, man, can't draw 2's. 2 lengths plus 2 widths. That's the perimeter. And the area is even easier. We just multiply the length times the width. And that's our formula for area. We multiply the 2 dimensions together. We multiply this dimension by this dimension. It's very critical that this is 90 degrees, which is by the definition of a rectangle it is. Okay, you need to have these all at 90. Moving on, triangles. Perimeter, you need to add, because triangles vary so much, you just add, it's the sum of all the sides, of all sides. Okay, so you just need to add up all the sides. Now for a triangle, notice how if we were to draw a rectangle and then we were to cut it in half to draw a triangle, this would represent the area of a triangle, right? This right here in blue. Okay, well it's the same thing. Okay, we just changed the labeling from length to width to base and height. Now it's important that the height is perpendicular to the base. That's very important. So this height for the formula needs to be perpendicular to the base. To base. Okay, so our area formula is actually the base times the height, like it is here, base times height, but what's the difference? It's not a rectangle, we have to divide by 2. Okay, another way to say that is 1/2 base times height, which I'm sure you have all heard before. Okay, now let's apply this. So we have what is the perimeter of the shape, what is the area? So we have here, looks like a rectangle with a semicircle. So the first thing we should probably do is let's take this 12 and put it on the other side. If it's a rectangle, it's on the other side. So the perimeter is just going to be the area, or sorry, not the area, the distance around this shape. So perimeter equals the distance around. We're going to start with here, go 12 plus 8 plus 12 plus, now we need to find this distance around the circle. Well, distance around the circle is known as circumference. Okay, so that is circumference. I don't know if I said that. Sorry. Circumference is the distance around a circle. Okay. Now this is distance around half a circle. So we're going to take our circumference formula, 2 pi r, and we only want half of it. So we're going to divide it by 2. Okay. Now the key is, what is our r? That's the only variable that we have. So we need to find this r. Where is it? Okay. This r, if this distance is 8, okay, if this whole distance is 8, well, the radius is always half the diameter. I'm not sure if I said that, but radius is always equal to half the diameter, because it goes all the way across the circle. A radius starts from the center and goes to the edge, okay? I don't know why I did such disservice to the circles, but please forgive me. Okay, so our radius here is half of 8, which is 4. So we need to apply this. 2 times pi times 4 divided by 2. So that's going to be equal to 8 pi divided by 2, or 4 pi. So we're going to add 4 pi onto our equation here. So we have 12 plus 8 is 20, plus 12 is 32, plus 4 pi. Technically, you can leave it like this, okay? But if you wanted to find out exactly what this is in decimal form, we can do that, and you get about 44.6. I'm rounding. Okay, so 44.6, we need to know the units. There are no units, so we're just going to say units. Area is a little bit easier, okay, than perimeter. Perimeter is actually a little bit harder. So area is going to be equal to the sum of the two shapes. So we need the area of the rectangle plus the area of the semicircle. Okay, so the area of the rectangle is easy. We do 12 times 8, length times width. Okay, we refer to this formula here. Area equals length times width. Okay, area of a semicircle. Area of a we'll just draw it. Semicircle is equal to pi r squared, but because it's half, we're dividing by 2. Okay, so we're going to do pi r is 4, but we need to square that first, and then we're going to divide by 2. So then we have 12 times 8. Well, we all know that is 96. Plus, we have 16 pi over 2. Area equals 96 plus 8 pi. So you could leave it like that because technically, I mean, that's rationalized. But if you want to find it in decimal form, I will show you how to do that real fast. Just add these together. 8 times 3.14 approximately, and we get 121.1. And that's units squared. Very important to put the correct units. Basically, every geometry math teacher is crazy about units. Sorry about that. That's just the way we are. Okay, let's put it in a real-world example. A house has the following floor plan. What is the perimeter of the house? What is the floor's area? A lot of different ways to do this. You can actually, I'm going to show you kind of a cool cutout way. So you could just break this down if you wanted into this rectangle, this little rectangle, and this rectangle, and add them. Okay, that's a common way to do that for area. Okay. Oh, I should probably do perimeter first. I'm sorry. I'm getting out of turn here. So we're going to find this. This distance here is 50. If we look across, it matches that this side over here. So that's 50. This is 100. So perimeter equals 50 plus 100 plus another 50 plus, what's this distance? Well, if this whole distance right here is 100, and this is 20, and this is 40, that's 60. So what are we missing to get to 100? We're missing another 40. So we have to add 40 plus 30 plus another 40 plus another 30 because it matches the other side, this side, okay, plus 20, and that's it. So we're just going to type this on our calculator. 50 plus 100 plus 50 plus 40 plus 30 plus 40 plus 30 plus 20. And we get 360, and we have units this time, feet. Okay, so we got the perimeter, 360 feet. Okay, I'm almost at 15 minutes. I think I'm going to make it. So I have just enough time to show you the cool way to solve this for area. As I showed, you can break it down into 3 rectangles if you want, but there's a cool way to do it that saves you time on the SAT and all that stuff. What we're going to do is notice how we have this little cutout here, this little shape. Okay, and we can find the area of this cutout, okay, that we don't want. And this area is equal to length times width, equal to 40 times 30. With 40 times 30, I think it's 1,200. 40 times 30. I don't know why I'm doing this. I know what it is, but I just don't want to. I'm just so scared to make a mistake. I guess we all get frozen sometimes, so that's feet squared. Now, that's just the cutout. I still want the whole shape, so what do? Well, I got to find... let's go orange. I got to find the area of this big whole rectangle. So if I find the whole area of this rectangle and I subtract this lawn area that I don't want, then I can find, so the area of big rectangle minus area of the small rectangle equals the area of the house. Equals area of the house. I have 30 seconds. How about that? Less than that. So the area of the big one is 100 times 50. Okay, 100 times 50. 100 times 50 is 5,000. So that's 5,000. I subtract 1,200 minus 1,200, and I get 3,800 feet squared for the area of the house. That's all time I have for. Thank you for watching. I'll see you next time on Wes Explains Best.